Okay, so today we are going to be working on measures of center. I think you've done this before in like 7th and 8th grade. A measure of center is a measure that represents the center of the data set. These are mean, median, and mode. Okay. The mean of a numerical data set is the sum of the data divided by the number of data values. So you might have also heard this called the average. This symbol, it's an X with a line over it. It's read as X bar. Also means mean. So it's just notation for mean. The median of a numerical data set is the number in the middle when the values are written in order from least to greatest. So think about on a street, when there's a median, it's in the middle of the road. And then the last one we're going to talk about today is the mode. This is the value or values, there can be more than one, that happen most often. Okay, so this first example says an amusement park hires students for the summer. The students' hourly wages are shown in the table. I first want to find my mean, so to do this, I'm going to add up all of my values. So I'm going to take the 1650, and I'm going to add it to the 825, the 875, the 845, 865, 825, 910, and 925. Okay, so does anyone have a value when I add those all up together? Yeah.
The sum of all those numbers is 77.2.
Okay. And then how many total numbers did I add together?
8.
8.
The average is 9.65.
How did you get that?
I divided the amount of numbers we had with the sum.
So we took 77.2 and divided by 8, which gives us 9.65, which is our mean. so to find my median, I need to list all of these in order from least to greatest, and then select my middle number. So what's my smallest number? Yazzie?
8.25.
Okay. So I'm going to cross these off as I use them so I don't double count anything. Then my next smallest number, someone else? Yeah, Casey? Okay, and my next smallest? Yep. Okay, my next one? My next one? Yeah, 8.75. The next? 9.10. Next one? 9.25. And my last one? 16.50. So if I go to look in my middle, what do I notice? There's two numbers in the middle. So what do I need to do to find my median? You guys remember? Yeah? Yeah, so I want to find the average of these two numbers, which is our mean, of those two specific numbers. So I'm going to do 8.65 plus 8.75 and then divide by 2. Which is going to give me 17.4 on the top and 2 on the bottom. And then when I divide, it gives me 8.7. So this is our median. And my mode is my number that appears most often. Which number is that? 8.25 appears twice, so it's my mode because it's the only one that appears more than once. What would happen if all the numbers appeared the same amount of times?
There is no mode.
Yep. If they all appear exactly the same amount of times, there's no mode. So, mean and median both try to measure the central tendency in a data set. The goal of each of them is to get an idea of a typical value in the data set. So typically we'll use the mean, but sometimes you would prefer the median. The median is best when there is an extreme value, and the extreme value would be called an outlier. So something that doesn't fit with the rest of them. If I think back to the first problem we did, we were looking at everyone's wages, and then for the most part people were making $8 or $9, but someone was making $16.50. That $16.50 would be considered an outlier. So it says the golf team's 6 members had the scores below in their most recent tournament: 70, 72, 74, 76, 80, and 114. So I first want to find my mean. So I'm going to add all of those numbers together. And then I know that it's for 6 people, so I'm going to divide by 6. So what do I get when I add the top numbers together? Yazzie?
486.
And then I want to go ahead and divide by that 6. Someone else, what does that give me? Okay, so this means that the average golfer on this team scores 81. I don't know, I don't golf. Actually, you want it to be as small as possible for golf. Okay, so for median, I'm going to rewrite all of my numbers in order from smallest to greatest, which these ones are already in smallest to greatest. And then I want to find the number in the middle. So there's 2 again in the middle. So I have to find my average here of those 2. I'm going to do 74 plus 76 and divide by the 2. 74 plus 76 gives me 150, and 150 divided by 2 is, see?
75.
Okay, so this one means the middle point in the set of scores. Okay, so which one do you guys think is better, mean or median for this particular example? Why the median? But does being lower mean it's better? So if I look at my mean, it's 81. Notice 81 is larger than 5 of those numbers. Does that feel like it's a good representation of the whole team? No, because one person did really bad. They had 114. So, yeah?
Then depends on, I guess, if it's a big drastic difference or something like that, because they're all pretty similar things coming out of your 1 and 2, but if one's like drastically different, then that would affect the whole thing.
Yeah, so I have to look at my particular data set, and this one, because 81 is drastically different from most of my numbers, I am going to actually go with my median for the best. So I want to take a look back at my front. On the amusement park hourly wages, which measure of center best represents the data? So if I take a look, which one feels like it's a better fit for the data? The 965 or the 8.7? The 8.7, because this 9.65 is, again, more than most people were making at the amusement park. So, my My median is the best representation there again. Oh, I spelled median wrong. Our mode was less than most of the data, and the mean is higher than most of the data. So those weren't good fits. Okay, so I kind of mentioned this earlier. The value of 1650 on the amusement park is way different than the rest of the values. This value is called an outlier. So an outlier is much less or much greater than the rest of the data. Okay, so an outlier will affect the mean, but it will not affect the median. So if I have an outlier, this is important when deciding which measure of center is best. Okay, so if I go back to the student hourly wages from the front, I'm going to copy those down. I want to take out my outlier, so I'm going to write down all of them except for that outlier. And I'll write them here so we don't have to flip back and forth. So the first thing I want to do is I want to find my mean without my outlier. So I'm going to add up all of those numbers together. So before I divide, what do I get when I add them all up together? Someone else. You've been helping us a lot today. Mm-hmm. And then I want to take this number and divide by 7. So 60.7 divided by 7 is 8.67. Okay. What about my mode on this set? Remember, mode is the one that happens most often. 8.25. Oh, my last one is my median, so that's the one in the middle. That one is going to be the 8.65. So what happens when I get rid of the outlier? Which of these changed from our numbers on the front? Corey, put your computer away. Just the median? Oh. Huh?
The mean and
The mean and the median, they both do what compared to the front? Go up or down?
of the mean, the outliers class to get that mean, as much as they're doing it.
Mm-hmm.
And without whether for median, it's just one less number of mean, just well, it's not even so it's not even better.
So both of these are smaller than our numbers on the front, so it's decreasing. Corey, put your computer away. Okay, so we have one more example. So this says, consider the data set and find the information below. It has 2, 5, 16, 2, 2, 7, 3, 4, and 4. So I want to find my mean. So what am I going to do to find my mean? So I'm going to add all of them together. What do I get when I add all of these together? Okay, and then how many total numbers did I have? So 45 divided by 9 is? Right, to find my median, what do I need to do? I want to put these in order. So I have 2, 2, 2. Then I have 3, 4, 4, 5, and then 16. So I want to find my number in the middle. You said it's 4? And then my mode? 2. Because it happens 3 times. And do I have an outlier? 16. It's twice as large as my largest number. So which one do you think is going to be the best measure of center here, and why? Yazzie?
Median, because 4 brings in much more than 5.
Okay, so 4, because it's a better representation. Of all of the numbers. Okay, B is showing the masses of 8 gorillas, so I need to, again, find all of these things. I'm going to start off by adding them all together to get my mean. the final answer? Or the sum? What is it? 1,100 and what? Is that what everyone else got? Okay. Then what do I want to do? How many gorillas were there? Okay. So to find my median, I want to write these in order. 44 is my smallest. So for this one, because I have an even number of numbers, I have to find the median between the two middle numbers. So this is going to be found by adding 159 and 160 together and dividing by 2. That gets me and my mode. And do I have an outlier here? So which one do you think is the best measure of center and why? Mean, median, or mode? Why do you think the mode's the best? Okay. Any other ideas here? Does anyone like the mean? And not just because it has 3 decimal places. It's way lower than most of my data, because with the exception of the 44, it's below that. This one and this one are both good ones, because they're both right in the middle. So I'm going to write the median, because typically you pick median or mean. So the median is the best fit because it accounts for the outlier. Okay, I'm going to skip the U-try because we're running low on time. And I need to get to the one on the back. So, this one says that Susan has 4 20-point projects for math. Her scores on the first 3 projects are shown below. So, she has an 18, a 15, a 16, and then we don't know what she got on her last one, so I'm going to use an X. We need to figure out what she needs to get on the 4th project in order for her average to be 17. So, we are going to find the mean. And I said we were letting X represent our 4th project. So I'm going to plug this in. She had 18, 15, 16, and X. And there's a total of 4 projects. What's the average she wanted to get? 17. So what do you think I should do? Once I set this up, it's like solving an equation like we did in the first semester. Yeah?
17 times 4.
I'll do that in a second. I actually want to combine like terms on my numerator first, just so I don't have those. So what's 18 plus 15 plus 16? Yeah.
49.
So now I have 49 plus x on my numerator over 4 equals 17. And then I want to get rid of the fraction, just like Zeke said. So I'm going to multiply both sides by 4. That's going to cancel out on my left. So I'm going to be left with, I'll write this over here, 49 plus x. And then 17 times 4 is 4. And then to solve for x, what do I want to do? And I get so she needs to get 19 points on her 4th project. Okay, so I'm going to do the you try with you. It says his math scores are 86, 93, 85, and 91. He wants to make his average a 90. What does he need to get on his next test to bring his average to a 90? So what I'm going to do, same thing, is I'm going to add those scores together. And then I'm going to add another score of x. How many total numbers am I adding together? Including the x. 5. And what do I want his average to be? 90. So then what's my first step? Someone else? Yep, add them all together. Huh? 355? Right. And then my next step? Huh? Not divide. I want to get rid of division. So the opposite of dividing is? Yep, I'm going to multiply both sides by 5. That's going to cancel out on the left, so I get 355 plus x. What's 90 times 5? 450. And then how do I get x alone? And I get what for x? 9? Oh, 95. So he needs to get 95 on his next math test to make his average a 90.